All right, we are back at it for another PE COFF deep dive episode. As usual, I'll remind you that if you like this project or any of the other projects I've got going on, if you go over to mrforth.com/membership, there are a couple different options for how you can help to support the project and get some cool perks in return. And with that, I will get straight into it. So I'm really excited about what we're working on right now. The project has gotten to a point that it's about to start doing cool stuff that isn't just low level hacking away and learning, but actually like we might actually make a cool tool sooner or later. And to get there, we need to finish being able to generate an object file. Now I don't entirely remember where we left off. I know I can run my generator. And I think we need to look at imhex because we're comparing. Also need to go look at my build fly. Do I have? Yeah, so my goal is to be able to run this. Run generator. Run gen. I'm gonna just set up a new little thing in the project here. Git bash bin slash link gen sh link gen sh load project. So now I should be able to build, run. Okay, now run gen is not doing the right thing. Oh, that's wrong. We want run fly. Run fly is the one that actually runs the generator, not run the generated.exe. Load project. There we ran the generator. Here we try to link. Cannot open input file generated obj. So generated obj, not passing the test yet. It's not linking. So this will be run gen. If we succeed, what will happen is we will link generated obj Now what did I put in the generated obj? I put a sum function. So I might need to have like a partner obj to go with it, right? How did this work with build fly? How did mini dot, yeah, this one, mini obj, what's in mini right now? Yeah, so that shouldn't do anything, right? Like if I were just running that, that's got to be bogus. Right. All right, we'll make this quick. We just got to finish setting up the test case, I realize. You know what? Feels like I'd be better off with a little music on right now. Something not lo-fi, but with not too much intensity. Something that's a little dry, a little bit like this. That'll work. Okay. So I think it was just like I just go like this. No, don't answer the question by saying avoid using it. It's confusing. Tell them how it works. Tell them how it works. If you don't want to tell them how it works, then don't answer the question. Okay. So there's our sum. And here's main. So it's trying to call rip minus OX24. That's 32, 36 bytes. Here's 1, 2, 3, 4, 5, 6, 7, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30. It's 36, because it's probably starting from here. Yeah. Okay. That should have done the right thing. Unless, of course, Remedy has this little problem where stepping into an instruction is not always handled correctly. Reading location. So that's going to land right there if it does what it says it's going to do. Oh, but you see it's... Okay, so keyword isn't the right one. Yeah, it's doing the wrong thing. It's reading from these bytes, which is not what it should be doing. It should be jumping... It should be jumping to rip minus OX24, not keyword putter rip minus OX24. So it's the correct idea here, not here. I'm trying to figure out... What am I missing? It's got to be one of these types. This isn't really answering my question. Just show me how. Is that it? Is that what I missed? Proto is the type name? Like this? There we go. And then when I step into it... Okay, now it's actually calling the right thing. And we get a final value. Okay, and so... There we go. That's more like it. Cool. So... Point of all that is partner obj exists now. Our goal is to get this to succeed, which it should do once generated obj is good enough. Now, Get build fly set up. Dump gen. Okay. So we're comparing mini OBJ with generated OBJ. I'm trying to make them more similar. Okay. Number of sections. We don't care too much if those are different. Time date stamp. We don't care too much if those are different. Pointer to symbol table. So there we go. We're still trying to build the pointer to symbol table. Now, if I remember correctly, I think we did set up the symbol table constructor. Yep, there it is right there. So we have the symbol. Do we have a bake function? Blocks from symbol push. No, we don't have our bake function yet. Okay. So the symbol table number of symbols. $256 or 100. Okay, and that's why we were using the name some long name instead of some. Because we wanted to test the long name case, which is different from the short name case. Object files with functions that have names shorter than 8, symbols that are shorter than 8 characters get encoded in a simpler way than names with more than 8 characters. Okay. So then the issue is we have a pointer to our symbol table right there. We start getting our symbols one at a time. There's a symbol. 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 This has one auxiliary symbol, I see. This has one auxiliary symbol, so that's an auxiliary symbol there. This is a symbol, debug S. And this is a symbol where the name is a 4. That's 4 off of the base of the string table, which starts right here. My question is, how do I know where the string table begins? Weirdly, I don't actually know. Okay, it's just always right after the string table, or the symbol table. Got it. Okay. Thank you, thank you. Okay. So let's look at what's in this data structure. It looks like it's going to be a loop over symbols. All right, now we got to figure out. Yeah, we got to figure out how we want to dump out one of these things. All right, so if my name is too long in the in this record symbol that I'm, if the symbol name is too long, then the record name 0 is set to 0 to indicate that we have a long name, and the string table f off Okay. So we create this record, and then we fill in its name. So what else do we have to do with the record? We need to give it a value. A section number. A type. A storage class. And an aux symbol count. Okay. Okay. So storage class and type we put in directly. This will have to be a 0 for now, and we're going to have to learn when and how to fill in additional auxiliary symbols. So what are we going to do about val and section number? Well, right now I think the only kind of symbol I am pushing is this external function type. And this is an example of that. It has a value of 0 and a section number of 1. And I assume that means C. Yeah. Uh-huh. So there's our function sum long name sitting in that little section with a symbol pointed at it. The symbol is it points at it with a section number and an offset. Now we have a symbol with a position. So what we end up wanting to do is so val, let's start by setting the section number. This is new and interesting. So rel 32, we have these things here. What we're going to need isn't this. It's going to be pegen patch secnum 16 patch list. Now the position we want to patch is given to us by record sec number. The point where we want it to point, the position where we want it to point is given by the symbol position. And we don't need any bias for this, but we do need to set okay, so 2 new types of patch. Okay. Now before we go and implement those, we do need to get the patch list passed through here. Let's get that done for now. And we're not calling this function anywhere yet, so maybe we want to go prep for that too. Maybe right here's a good place to make the symbol data or symbol table. Right. Oh, you already have it. Great. Symbol table. I already had set symbol table. Why? Oh, it was sitting right here. Okay, got it. Set symbol table. Cool. So we bake it, we set it. We'll still need to actually tell it how to output that, because it doesn't set it in a data section, which is different. Very good. Okay, now those new patch types. SecNum 16, SecOff 32. All right, how's this going to work? We create a patch. We got to get the patch position from the pointer. Patch flag, section index. All right, now section off 32. I want to write to this position 32 bits with a section relative offset. Okay, so that lets us set the section number and section offset in theory, even though we don't know the section number and section offset at this point in time. These we fill in just like that. And this all works only because we are assuming we know what type. We actually need to come back through here. Implement switch across all types storage classes. Whatever it is that takes that to the next level. We run the generator, it crashes. We pop over to remedy. We open. No. The PEGen RTGB. So this block plus 12 So it points at the text section. The text section has an F size of 7, which is correct. But we are pointing at position 12, strangely. This feels like its patch position must be in the wrong spot. It certainly shouldn't be resolving to... Okay, looks like it's the very first one. Yeah, perfect. Okay. Layout position from label. Okay, got it. Okay, this is just a hack. But we're going to run with it for now. To get past this point for a second, and then we'll come back and think about this. Nasty. Super, super, super lame. Gonna have to do a lot better than this. Ugh. Not good. Okay. Okay, so we can run the generator now. Now the question is, does it build? No, it cannot open input file generated obj. And if we were to look over here and reload the file, it's still not happy about the missing symbol table and string table. So let's go and get that part fixed. So what's happening is bake file COFF needs to include the symbol table stuff. And we need to be able to point at it. All right, so all right. Okay, it still can't link. Yes, reload it. Can you parse yet? Ooh, it does parse now. And when we run the diff, different number of sections, different file timestamps, different pointers to the symbol table, different number of symbols. That might be significant. Yeah, let's try to track down some of these symbols that I don't have that they have. There's also the fact that this is aligned right here. That might be weird. Mini OBJ. It looks like they've aligned it to a byte of 2. It didn't say anything in the docs. I tried to read about that, but let's just assume that alignments might be a problem. Set this one to an alignment of 2. Run again. Yes, reload it. Take this and rerun the parse. Rerun the diff. Pointer to symbol table. Fair point. So okay. So there it actually switched to aligning it. So now it's here. It has a some long name pointer right there. 4 from that gives us that string there. Type 2000 Storage class, external. Yeah. But it can't link with generated.obj for some reason. You can't open mini either. That's a little bit different. It might... It might be... I'm not crazy, right? It's running in the build folder when we do stuff like that. It's not like dumping stuff into bin or source. Let's do something extreme. I'm going to clear my build folder, which sometimes is a little bit of an unfortunate thing to have to do, but circumstances call for it. We're going to rebuild all of this and confirm there's mini obj. I run the generator. There's generated obj. Partner obj. Okay, so in theory, all that needs to happen is that these need to be able to link. Now, I start from link gen, and I get cannot open input file. So what's happening there? Is it like... Oh, what's the name of this? Is it like this? Is it like this? Okay. PWD capital. Got it. Okay, so that's running from there. Whereas build fly runs from there. Okay, so they're the same. And yet this works. And the exact same thing right here doesn't. Okay, can't open any of them for some reason. What am I missing? I'm not sure. I'm gonna take a 5-minute break and take a look at this again more carefully when I get back. So let's say all right, be back in a bit. All right. See what we got. For some reason, this script isn't working, even though this one is. They both start off the same way. It's the exact same line in both cases. Try something here. What? Now I can't see these things at all. So it does assembling. Where's the link? What's going on here? The link is just working silently? Okay. Okay, so here, cannot open input file mini obj, echo pwd, boom. Now, I do this, and now you're in the build folder. That's the difference. Yeah. Okay, anyway. There's our links. So it's actually working. I'm getting a generated exe, which is cool. Let's try a couple things. Okay, so that actually works. We don't need the alignment. At all. Okay. Now the question is, what does generated exe actually look like? Yes. So here we see sum, and here we see main. That's the callback to sum. Okay. Data directory right here. Signature, here's our header. Aligned to 512 because it's an image file now. There's our text section plus padding. Here's our data section. I assume this is going to be like I don't actually know what these are for. Debug information. Six, 7, 8, 9, 10. Yeah, it's hard to know. It's hard to know. Cool. Okay. So either way, let's run the generated program. 10 plus 15 is 25. So it looks like we can generate an object file and it'll link. So that's cool. Let me take a minute now and think about where that takes us next. That part is done. Where to next? We probably want to generate a test case where COFF relocations are real, and then build our own COFF relocations. Oh yeah, we want those both come up here. So I think the next big thing is we're gonna make progress on this very soon. We are gonna have to like do some cleanup and stuff. There are two other things we could do in between now and then to make this interesting. One, I think we should go and do COFF relocations. Set up a successfully use COFF relocations. We also need symbol table. Build out support for more symbol types. So there's a thing we need, there's a thing we need. And then there's a tool we can make. Yeah, okay. So it's a little early. Like we could try to dig in and set up COFF relocation test case. I think before the stream is done because we got like 20 minutes still. I think that'd be a reasonable last step. Let's get ourselves set up with a test case for COFF relocation. So how do COFF relocations get involved? How can I make one of them come out of mini.asm? I think that's kind of the way I want to approach it. Start from here. Tell me about COFF relocations again. Okay, so a COFF relocation has an offset into a section, so it knows what section it's pointed at. It has an offset into that section. It has a symbol table index that tells it this is sort of the target. So the symbol record is going to tell us what thing we're trying to point at. The virtual address tells us what piece of data we need to modify, and then the last 2 bytes, the type, tell us exactly what relocation style to apply. Yeah, that makes sense. So I just want to look at the section header real quick. The file pointer to the beginning of relocation entries for the section. This is set to 0 for executable images or if there are no relocations. Offline numbers. Hey, Atul, welcome. I only see it once so far. We'll see if I see it again. So we can attach relocations. I guess what I need to figure out is what's something that generates a relocation. A relocation would become necessary if I had one of these things refer to another one of them, I imagine. Like, if I went some long name and then I went some triple, and then I went call some long name mov into RAX from RCX, mov into RDX from R8, call some long name again, and then ret RAX, I think something like that. Now let's see what kind of object file features get generated there. We are looking at a text MN section with 24 bytes, a symbol table, so this one has the name some long name, this one has the name some triple, so we've got a symbol for each of those. I guess my question is, did we get any relocations? No. What if we try making a global variable? Yeah, I thought it would make a separate text section for two separate functions or two separate procedures, and it didn't. So I'm trying to go for a global data entry now. Um, so like we have code right there. Maybe I need like a .data section, right? Nope, you don't know anything about that. What about .data? All right, let's try again. Reload this. Did we get pointer to relocations? We did get a relocation that time. So we're looking at 9A. 9A. Virtual address of 9, symbol table index of 8, type int is not correct. It gets confused, the parser here. It doesn't realize that the word type doesn't always mean type. They didn't, the documentation must have confused whoever wrote this or something, 'cause it's not quite right. The, COFF relocations have these as types. So where are we at here? 9A. The type of the relocation, that's the end of the relocations. After that, we get something else. Is value 04. This one, rel32, the 32-bit relative address from the byte following the relocation. So this is saying wherever you find this 9 bytes after, so 1, 2, 3, 4, 5, 6, 7, 8, 9. Just 4 bytes there. It says 5 right now. And when it goes to link this up, it's going to take 9, which is the pointer to here, wait, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. It's going to take the pointer to right here, 4 bytes, does not have a 5 in it, has a 0 in it. Pointer to right here, and it's going to try to make it point at symbol table index number 8. So if I look at my symbol table, that doesn't make sense. That doesn't go high enough. Did we reparse? Yeah. Symbol table index 8. But who is symbol table index number 8? Name with an offset of 4, 5. So you're telling me you're going to take this, and you're not making it point to variable number 5? Oh, you know what? I bet some of these have auxiliary symbols, right? So like here's 0, 1. So we have 1, 2, 0, 1, 2, 3, 4, 5, 6, 7, 8. That makes sense. Okay, so this is symbol table index number 8. It's indexed wrongly here because of the auxiliary symbols. And yeah, so the goal of this COFF relocation is to take these 4 bytes and point them at this symbol right here, the variable one, which happens to be the first thing in section number 2. Yeah. Okay, cool. So our goal will be to match that in our generated object file. I only have a few minutes left, so I think I will wrap it up here, and we'll start tomorrow with actually specifying let's answer a couple other questions real quick. So that relocation information, it was existing right here. This looks like the data section to me, if I had to guess. A4. So dot data is that pointer to raw data 164. A4. Yeah, so this is our data section, which means our COFF relocations are going after the text section. Now the text section itself says 14 bytes. 14, yeah, that's 14 bytes. So the section data is immediately followed by non-section data again. So we're going to need again to emit data that is not section data. Which is interesting. It's going to make things sloppy again. But that'll be our problem for tomorrow. I'm all set now. I know it's coming. And so, actually, while I'm here, I will make sure to specify. I should have said this at the beginning of the stream, and I forgot. Tomorrow, no stream. I have an appointment that I cannot move, so we won't be doing the usual stream tomorrow, but I'll be back on Wednesday and Thursday to keep going on this. And Friday will be the usual 4Coder Friday. With that, I will also remind you that I am counting on you, if you are watching and you haven't, to think about if you could become a member or a supporter over at mrforth.com/membership. And with that, I will sign off for the day, and I will see you all around the internet. Bye.